remember we want to write it in descending order of powers. So our x cubed term would come first. Okay. 7x cubed. We have a group called x cubed. How many are in that group? We've got 2 and 5. So there are 7 in the group x cubed. We've got a group called x squared. There's -4 and -6 for a total of -10 in the group x squared. For multiplication of variables, the rule is add the exponents. In this example, we have 2x cubed, y to the 5th, times 4x to the 4th, y to the -2. Now we have coefficients here. What do you do with those? You multiply them. Okay, it's a whole number. You're multiplying 2 times 4. For the x's, we are adding the exponents of x. And for the y's, we are adding the exponents of y. So why do I have 5 minus 2? Because you're adding a -2. All right? So the answer to this is 8 x to the 7th y cubed. This is old stuff. It's stuff some students are still struggling with. Division of variables. Subtract exponents or just simply cancel. In this example, we've got 16x to the 4th, y to the 5th, divided by 4x to the 8th, y cubed. Canceling is actually a lot easier because then you don't have to get all messed up with the negative exponents and where does it go, and do I flip it, do I not flip it, what's happening. So if we look at the coefficients 16 and 4, can they be reduced? Yes. When I look at the fact that I have x's being divided by x's, the question is, where are there more x's, in the numerator or denominator? In the denominator. How many more x's?
4.
There are 4 more x's in the denominator, so that means when I cancel, I have 4 x's in the denominator. And for the y's, since they're both at the top and the bottom, where do you have more? How many more? 2 more. And then so you simply write out what you have left. At the top we have 4y squared. And in the denominator we have x to the 4th. God bless you. And then finally, on the exponent rules, when you raise a power to a power, which means if you're raising x cubed and then you're cubing it again, you multiply the variables. So if you think about it, it's an order, it's a sequential order that takes place. Let's do this and then I'll write that down. Maybe it'll help you to remember. Now for the coefficient, you've actually got to cube 4. And that's not 4 times 3. It's 4 times 4 times 4, which is... But for x cubed, we're simply going to multiply those exponents together to get x to the 9th, y to the 15th. Okay, now the sequence that I was talking about, write this smaller. You're adding and subtracting variables, you do nothing to the exponents. When you multiply and divide variables, you add and subtract the exponents. When you raise a power to a power, you multiply the exponents. So if you look at the order here, I've got addition and subtraction moves on to multiplication and division. Here we start by doing nothing, we move on to addition and subtraction of exponents, and then we move on to multiplication of exponents. So if you see, there's a sequential order that follows. And I hope this helps you just to remember. Instead of trying to remember a rule verbatim that makes no sense to you. Okay, radicals. You're going to work with radicals. The first thing is, when you're adding and subtracting, you're going to want to simplify the radical. You're only going to add them together if they are alike. And just like with addition and subtraction of variables, where the exponent didn't change, the radical doesn't change. Same exact thing. So if we have an example such as 2 square roots of 50 plus 3 cubed roots of 27 minus the square root of 32. Okay, well, it says I can only add them if they're alike. And none of them have a radical that's alike right now, but I first need to simplify because they might. What's that? Yes, this is a cubed root right here. Okay? So, starting here, 50 is 25 times 2, correct? And 25 is a perfect square. What's the square root of 25? 5. But there's already a number out here. So what I'm going to do is I'm going to multiply those together. So this reduces to 10 square roots of 2. 27 is under a cubed root, and 27 is a perfect cube. 27 is 3 cubed. And I've already got a 3 out here, so I'm going to multiply them together. Now if you take everything out from under the radical hat, what happens to it? It disappears. You're done. You've simplified it. It's gone. And then in this last one, 32 is 16 times 2. And 16 is a perfect square. What's the square root of 16? 4. Now that it's simplified, do you have radicals that are alike? God bless you. Yes, the 2 square root of 2 radicals. So we're going to combine them by putting the 10 and the negative 4 together and not changing the radical, which would give me 6 square roots of 2. And what do I do with plus 9? A plus 9.